Hey there, hi, it's Margaret and David, coming to you from a new high tunnel in the mountains of West Virginia. Well, it's March and it just snowed again, so gather around the fire and we'll give you a glimpse of what it took for us to finally get to the point, after a long process, to finally get to the point of planting. There's no power or water to this site. Plus, we had to level it, so David rented an excavator, and a guy named Rabbit came over and delivered it and showed David how to use it in like 5 minutes. And I gotta tell you, about 8 million screws later, and a couple of fights later, we finally have something that looks like a high tunnel. And I'm really glad. But it also sort of compacted the soil. But, we just had to keep rolling and get this thing built. Luckily, a couple of friends came over and helped pull the plastic. And this is 2 layers of plastic. And that finally, something came up kind of quick on this thing. We solarized, and then we also got in some composted cow manure. To celebrate what finally looks like rows and a high tunnel that might grow plants, we put in some seedlings and also some cover crop seeds, tillage radish, buckwheat, mustard, and some calendula seeds that I gathered last year. Not too hard, because the water will help get the soil around the roots. What's up? So exciting.
That's it.
The plan was to put in 7 rows, to optimize the space, and to do that using string lines. As you'll see in this process, that didn't quite happen.
So here we're using our BCS. We got the 749, and on the back we've got our rotary plow. We happen to buy the tilting or swivel rotary plow because our terraced garden up on the hill, when you run from one end to the other, you don't want to have to walk back the other direction to get the dirt to flow left or right. So here, because we're just trying to make rows, or basically raised little beds, we want the dirt to flow always to the right hand side. This was the first time both of us had done this, and so it took a little bit of getting used to. The rows are pretty straight, but the problem was the width was off a little bit. But the rotary plow does a really good job. It basically digs a hole, throws the dirt to one side or the other, and then after that, we're going to have to go through and run our power harrow over the top. You can see Margaret here just kind of smoothing out one of our rows and seeing what we got. And we kind of decided using the power harrow going to be a little more difficult to try to get our rows nice and neat. And so we just went through with a couple of rakes and hose to get the rows piled up nicely.
At first, laying out the rows using a string line seemed like a really good idea, but that only lasted for 1 row. And David and the BCS did just fine, and the string line created unnecessary extra work for me. So I decided the rows are straight enough, and I'll use the string line when putting plants in the ground later. And we were able to come up with 5 rows, 30 inches each. And because of the way the sidewalls work on the rows and the walking paths, there was no way we were going to fit 7 rows in at this point.
Here we're running the main line for our irrigation. We're using a 3/4 inch poly tube that we bought with the rest of the stuff that we had. We'll talk about that in a little while. Put a cap on the end, got it nice and straight. And then of course we got about 100 feet of this because we're going to use it elsewhere. So coming up here, I'm going to actually just trim it off. We'll leave some extra just in case and get it all connected temporarily. Here we're just getting ready to pull our first 2 lines of drip tape. There's going to be 2 per row, and again 5 rows. I'm going to get this hooked up, and then here I'm temporarily connecting our main line to our storage tank just to make sure everything works and I'm happy with it. I didn't want to punch up a whole bunch of holes and run a bunch of drip tape just to find out something was wrong. I think it was a good idea to go over all the pieces that we purchased for the drip irrigation system. We wanted to keep it as simple as possible. And right now it's kind of temporarily hooked up because I do need to get a couple of extra pieces and parts. I need some fittings, and we have to install a fertilizer injector, which we have not purchased, but we know which one we're going to get at this point. So let's just make it simple. The emitters are every 8 inches, and it is a 15 mil tape. Emitters put out 0.5 gallons per hour. So our rows, our total height tunnel is about 48 feet long. The tape row is probably around 40 feet. So if you do the math, we're talking about approximately 15 gallons per hour per tape, or 30 gallons per hour per row, and 150 gallons if we just do the whole thing per hour. We have a 1,100 gallon rain catchment system. We're going to have 1,500 gallons that is going to go on the new barn for rain catchment. So between those two, we're going to have plenty of storage through the driest part of the year. We should. But in addition to that, we have another 500 gallon tank that I will use that will take overflow from the tank up here. And then that will give us a total of like 3,000 gallons that we can use during the driest part of the year, when we don't get a lot of rain for about 2 to 3, 4 weeks, and that should cover us. So let's go over the parts, and hopefully that helps any of you figure out what you might need, because it took me a while to figure out. So first thing is, we have our water supply coming in. So this is a 1-inch line coming in from our tank up above. Again, this is temporary. We have not plumbed it into, a little system. We're going to do that as soon as we get our fertilizer injector. So the 1-inch line comes in, we have a shutoff valve, and then when I originally purchased some of this equipment, it was the easiest for me to get hose bib connectors for the filter, because it was going to be easy. This filter is like $7. It's a 150 mesh filter, which I think translates to like 200 microns. You double check on that. We have it connected to a Y, so we can have a hose connected, regular hose connected to it, but this goes out to the main line, and this is a little long right now, so we can figure out where it's going to go. And then the main line goes all the way down to the end over here, and it does have a cap on it. And that's all we need for that. The next part is we have all of our drip tape connectors. So this is a barb connector, and that goes straight into the drip tape. And this is a easy lock, I believe is what it's called, connector. And then I decided it was probably a good idea to have every one of these as a valve. You don't need to have them all as a valve, but I wanted them all to be a valve, because if we wanted to shut off any rows for any reason, we can do that, and it's super easy to do, especially if maybe we don't need 30 gallons an hour on a particular row and we only want 15 gallons an hour, or maybe we're running fertilizer and we only want to run fertilizer in certain sections because something needs a different type of fertilizer or a little more fertilizer, etc. We'll be able to do that. So I thought it was very important to make sure everything had a valve on it. And the final thing I also forgot to mention is that we also need a timer. So along this wall, I'm going to just build a little, plywood structure, or maybe a couple of posts in the ground. And then I'm going to have, obviously, this filter that we already have. We're going to have a timer, and then we're going to have our fertilizer injector. And then that will go straight into our main line, and then down the row. So that part is super straightforward and super easy. This didn't take us long at all to install. It was just a matter of rolling them out. And then the last thing, obviously, for here, every one of these was cut. So there is a little kind of crimp end on these. And it's just basically you fold the tape over and jam it in. I wasn't going to get them, but then I thought, well, they're actually pretty affordable, and it would be much easier than trying to, cob together some sort of solution when those just work. There's a couple extra ones in case we needed some extra line, etc. All right, so let's go look at our tank and how that's set up and go over those. So here's our main line. I shouldn't call it the main line. Here's our supply line coming in. Again, this is temporary. We're going to make this look a lot more permanent here as soon as we get the rest of our parts. Up here, this white tank is our 500-gallon tank we got from a friend of ours, and that will capture overflow from the main tank. So this just needs to kind of have a spot to be put in, and then I will connect this up with a T or something so that we can turn that on when we need it. And up here's our main tank. This is the 1,100-gallon tank we have, and it does catch rainwater off of our storage shed here. Storage shed, the roof on the storage shed is about 21 by 12 of the area that it's catching approximately. I do have another 6 by 21 that I want to capture from, but at this current stage, we're getting about 200 gallons of water in this tank for every half a gallon of rain that we get, or sorry, half an inch of rain that we get in a day. So in a nutshell, it's going to take somewhere around 5 to 6 inches of rain to fill this tank. It's got a simple connection. It does have the union on it, so this is easy to take off. All we got, and it's pretty straightforward. This basically runs through, or from a our water catchment, goes through the screen. These things are wonderful. They're a little expensive, and I think I bought these at Rain Brothers off the top of my head, so you would have to go check for that, but they're, I don't know, 30 or 40 bucks, so they're not cheap. I did not get the metal ones. I got the plastic ones because you can easily dump this screen out. If you get the metal one that somebody offers, you literally have to kind of take it apart, and I was not thrilled by that idea. So this isn't quite done, but it's getting there, and it works.
If you like this video and want to see more of what it takes to live on a partial off-grid mountainside homestead here in West Virginia, click the subscribe button.